Good evening, everyone. I'm here to share a simple document on some standard questions asked in the GCE O-Level Physics Singapore version. So I will share some questions through this document, and I hope you will support me by clicking subscribe and like my video. By clicking subscribe, you will get update of my latest video in my teaching of sciences. Now, the GCE O-Level Physics 2022 will be conducted in 2 weeks' time. So it will be a good time to do a simple summary of the standard questions that may appear in this year's paper. Question 1, how to measure using vernier caliper? Grip the object gently using outside jaws of calipers. Read the main scale to immediate left of the zero mark on the vernier scale. Read vernier scale, add vernier scale reading to the main scale reading. Question 2, how to measure using micrometer screw gauge? Turn the thimble until anvil and spindle are almost touching the object. Turn the ratchet until it clicks. Read main scale reading to immediate left of edge of thimble. Take the thimble reading that's aligned with the dotted line of the main scale. Take the diameter of the object by adding thimble reading to main scale reading. How to measure period? Measure the time taken for object to make 20 oscillations. Repeat to take time for another 20 oscillations. Calculate the average time by taking T1 plus T2 divided by 2. And calculate the period by taking T average divided by 20. Explain how terminal velocity is attained. Object falls from rest with acceleration due to gravity. As object falls with increasing speed, the air, water, or liquid resistance opposing motion increases. As the weight remains constant, when the resistance increases, resultant force acting on the object decreases. When the resistance equal to the weight, the resultant force is 0. Acceleration is 0 and object move at constant speed. Explain stable equilibrium or why object is able to restore to its original position when tilted. When object is slightly tilted, the center of gravity rises before returning to its original height. The line of action through center of gravity or weight lies within the base. Moment about the contact point C causes object to restore to its original position. Explain unstable equilibrium or why object topples when tilted. When object is slightly tilted, the center of gravity drops. Line of action through the center of gravity lies outside the base. Moment about contact point C causes object to topple. Explain neutral equilibrium. When the object is slightly displaced, center of gravity remains at the same height. The line of action through its weight and contact force coincide. Moment of its weight about contact point C is 0. It stays in the same position to which it is displaced. How to calibrate a thermometer? Immerse the bulb and lower end of thermometer stem into a funnel containing pure melting ice at standard atmospheric pressure. When the liquid level in thermometer stem remains steady, make a mark L0 at that level on the stem which correspond to the lower fixed point, ice point. Insert thermometer into apparatus containing pure boiling water at standard atmospheric pressure. When liquid level in the thermometer remains steady, make a mark L100 at that level on the stand that corresponds to the upper fixed point, steam point. Divide the interval between the two fixed points to 100 equal parts, with each interval represents 1 degree Celsius. Explain why solids have high density. Particles are closely packed together in regular pattern and occupying minimum space. Large number of particles per unit volume. Explain why solids have fixed volume and shape. Particles vibrate about fixed position. Particles are held in position by very strong attractive forces between the particles. Explain why liquids have high densities. Particles are randomly arranged and slightly further apart than in solids. Slightly smaller number of particles per unit volume compared to solids. Explain why liquids have fixed volume but takes the shape of the container. Particles are free to move about in liquid, and there are attractive forces between the particles. Explain why gas has low densities. Particles are randomly arranged and far apart from each other. Small number of particles per unit volume. Explain why gases have no fixed volume of shape and compressible. Particles have very little attractive forces between them, and they move about randomly at high speed. The particles occupy any available space. Just take a while to digest it before we carry on. Explain how air molecules inside container produce a pressure on the walls of container. This is a very popular question. When air molecules collide with inner wall of container, a force is exerted on wall. By Newton's third law of motion, equal and opposite force is exerted by wall on the molecule. Many collisions between air molecules and the wall produce an average force exerted by molecules on the wall. Force per unit area give rise to pressure exerted by molecules on the wall. Explain how temperature affects the pressure of gas. When temperature rises, the average speed of gaseous molecules increase. Also should mention average kinetic energies and speeds. The gaseous molecules bombard inner surfaces more vigorously and frequently. The average force per collisions between air molecules and walls increases. Since volume is fixed, pressure inside container increases. Explain how volume affects pressure of gas. With decrease in volume of gas, the number of molecules per unit volume increases. Gas molecules collide more frequently with inner surface and results in greater force. Force per unit area give rise to pressure exerted by molecules on the inner surfaces. Explain how temperature affects the volume of gases. When temperature rises, the average speed of gaseous molecules increases. The gaseous molecules bombard inner surfaces more vigorously and frequently. Gas molecules increases, and when exceeds atmospheric pressure, if exposed to atmosphere, net force acting outwards. Volume of gas increases and will stop expanding when the pressure of gas equal to the atmospheric pressure. So we should also mention kinetic energy as well. So whenever temperature was mentioned, it's important to also include kinetic energies of the molecules. Describe conduction in non-metals. Solids. Particles at hot end vibrate vigorously about their fixed positions. They collide with neighboring particles and making them vibrate more vigorously. Kinetic energy of vibrating particles at hot end is transferred to neighboring particles. Kinetic energy, I beg your pardon, thermal energy is transferred without transfer of particles. Eventually, particles at the cooler end are set into vigorous vibrations. That explain how conduction takes place in solids. In addition to process in question 19, this is for conduction in metals. Thermal energy is transferred faster with free electron diffusion. Free moving electrons at heated end absorb thermal energy and gain kinetic energy. The electrons move at greater speed and move to the cooler regions. As electrons move, they collide with atoms in cooler parts, making them vibrate more vigorously, and the kinetic energy of the moving electrons is transferred to these atoms. Thermal energy is transferred via motion of free moving electrons. State differences between boiling and evaporation. Boiling occurs at boiling point, while evaporation occurs at any temperature. Boiling is fast, while evaporation is slow. Boiling takes place throughout the liquid, but evaporation only occurs on the surface of the liquid. Bubbles are formed in liquid during boiling, while no bubbles are formed in liquid during evaporation. Temperature remains constant during boiling, while temperature changes during evaporation. External thermal energy source required for boiling, but external thermal energy not required for evaporation. Explain how evaporation occurs on a molecular level. The molecules in liquid are always moving randomly at different speed as they have different kinetic energies. At the surface, the liquid molecules have enough energy to overcome downward attractive forces of other liquid molecules and atmospheric pressure, escape into atmosphere. The less energetic molecules are left behind. The average kinetic energy of the molecules in liquid decreases, and average temperature of the liquid decreases. Explain what happened on a molecular level when a solid melts. The particles in solids are held together by strong bonds. The particles are closely packed together. Internal potential energy of solid is lower than liquid. Thermal energy is absorbed to break the strong bonds between particles. Internal potential energy increases. None of thermal energy supply is converted to internal kinetic energy, hence no change in temperature during melting. The particles now move out of their fixed positions and become further apart from one another. Explain what happened on a molecular level when a liquid boils. The intermolecular bonds between liquid particles are weaker than those in solid, but still strongly held together. Particles are slightly further apart in disorderly arrangement and slide past each other. Thermal energy is absorbed to break the strong bonds between particles and provide energy for the molecules to push back on surrounding atmosphere. Internal potential energy increases. None of thermal energy supply is converted to internal kinetic energy with no change in temperature during boiling. The particles now move much further apart from each other and at high speed in random directions. Explain what happened on a molecular level when a liquid freezes. The intermolecular bonds between liquid particles are weaker than those in solid. Particles are further apart. Internal energy of liquid is higher than a solid. Thermal energy is released to form strong intermolecular bonds. Internal potential energy decreases. None of the thermal energy released is converted from internal kinetic energy, hence no change in temperature during freezing. The particles are now held at fixed positions close to each other in orderly arrangement. Describe the difference between sound or ultrasound and EM wave. EM waves are transverse waves that propagate in a direction perpendicular to the direction of vibration, while sound is longitudinal wave propagating in a direction parallel to direction of vibration of the particles. EM wave can travel through vacuum, but sound wave cannot travel through vacuum. EM wave travel fastest in gas, followed by liquid, then solid, while sound wave travel faster in solid, followed by liquid, and then gas. Describe the similarity between sound or ultrasound with EM wave. Both transfer energy from one place to another. The wave speed equation is applicable for both waves. When the wave travel through from one medium to another, speed and wavelength change, but frequency is unchanged. They obey laws of reflection and refraction. They carry no electric charge. State the applications of EM wave. Radio wave, radio, microwave, microwave oven, or satellite TV. Infrared radiation, remote controller or intruder alarm, visible light, optical fiber, or enable us to see our surroundings. UV radiation, sunbathe, or sterilization. X-ray radiation therapy or flaw detection. Gamma ray cancer treatment. State the effects of EM wave on living cells. Heating, ionization, damage to living cells. Describe an experiment to measure speed of sound in air. Using measuring tape, measure distance between observer A and B in open field. Observer A fire a piston. On seeing flash from piston, B start the stopwatch and stop when he hears the sound. Record the time interval. Calculate the speed of sound by taking the distance between them and divide by the time interval. Repeat experiment a few more times to calculate the average speed of sound. Repeat experiment but interchange position of A and B. Describe how electrostatic charging by friction occurs. When glass rod and silk rub together, atoms of surfaces are distorted. Electrons from atoms of surface of glass rod are transferred to the silk. The glass rod loses electrons and becomes positively charged. The silk gains electron and becomes negatively charged. Describe how to charge two metal spheres by induction. Place two conducting metal spheres on insulating stand side by side so they touch each other. Bring a negatively charged rod near but not touching sphere A. Electrons in both spheres are repelled to the far end of sphere B. Sphere A has excess positive charges and B has excess negative charges. While holding the charged rod in place, pull sphere B away from sphere A, remove the charged rod. Sphere A and B have equal number of opposite charges. Sphere A and B have been charged by induction. Describe how to charge a single metal conductor by induction. Bring a positively charged glass rod near a metal conductor on an insulating stand. free electrons in metal are drawn towards the end near the positive charge glass rod. Without removing the glass rod, earth the positive charge end of the metal conductor by touching it with your hand. This neutralizes the positive charges on the end of conductor. With the glass rod still in place, remove your hand from conductor to stop the earthing process. Remove the glass rod. Negative charges will redistribute themselves throughout the conductor, and the conductor is now negatively charged. For the earlier question 31, you are trying to make sphere A and B of opposite charge, which you can use either a negative or a positive charge rod. Of course, if you use a positive charge rod here, the answer for this will be different. Instead of electrons repel to the far end, electrons are all attracted to the side of the sphere A close to the positive charge rod, with the positive charges in excess remaining at B. For this question 32, if you want to make the conductor positive charge, you can do the opposite by bringing a negative charge glass rod near to the metal conductor instead. Okay, but the flow of charges will be different. So in this case, the positive charges are neutralized. But if you use a negative charge rod to make it into a positive charge metal conductor, then it will be the negative charges being neutralized instead. Describe how do we discharge a charged insulator. Brought the positive charge rod near a flame. Intense heat from the flame will ionize nearby air particles. The ions will neutralize excess charges on the glass rod, and the glass rod is discharged. Or allow the negative charge balloon float in humid air. Water molecules in air which are conductor will cause the excess charges on balloon to be transferred to water molecules from the surface of the balloon. How do you discharge a charged conductor? Earth the sphere by touching with your hands. For negatively charged sphere, excess electrons flow through the body to the earth. For positive charged sphere, electrons will flow through the body from earth to neutralize the excess positive charge. Remember to include the word excess. How principles of electrostatic work in photocopier. The metal drum coated with selenium and only conduct electricity in presence of light. The drum is charged positively initially by rotating the drum near highly charged wire. The original image to be photocopied is placed on a sheet of clear glass above the drum. Intense beam of light shone on the image. Darker areas of image reflect less light. Corresponding regions of drum remain insulating, and positive charges remain on the surface of the drum. Lighter areas of image reflect more light onto the drum, and the corresponding area become conducting and are discharged. As the drum rotates, the positively charged image on drum attracts the negatively charged toner powder in the toner cartridge. A positive charged sheet of paper is passed over the drum surface. Negatively charged toner powder is attracted away from the drum and onto the sheet of paper. The sheet of paper is heated and pressed, fusing the toner to the sheet of paper permanently. Explain how principles of electrostatic work in electrostatic precipitators. Waste gases and fly ash pass through negatively charged wire grids. Fly ash particles become negatively charged. Fly ash particles are then rolled past metal plates that are positively charged or earth. Metal plates attracted negatively charged fly ash particles. Gas living plates are free of fly ash particles. Explain how principles of electrostatic work in spray painting. As spray of paint leaves nozzle or spray paint gun, the particles of paint become charged by friction. The paint particles contain light charges, so they repel each other and spread out as they leave the nozzle. Charged paint particles attracted to the metallic surfaces to produce uniform coat of paint. Explain how principles of electrostatic work in Van der Graaf generator. A sealed belt passes repeatedly over two rollers and gets charged in the process. The positively charged comb at the bottom draws electrons away from the sealed belt, leaving positively charged particles on belt. Positively charged particles carry up to the metal sphere. Comb at top transfers electrons from metal sphere to positively charged belt, which discharges the belt before it returns down pulley. Metal sphere become positively charged and the spherical device become negatively charged, which creates a potential difference between them. Explain why filament lamp does not obey Ohm's law as current increases. As current increases, the device generates more heat, temperature increases. Resistance of filament increases with increasing temperature. Since resistance increases, gradient of IV graph is not constant and show decreasing gradient. Explain IV graph of semiconductor diode. When PD is applied in the forward direction, current flow is relatively large. Resistance is therefore low in forward direction. When PD is applied in the reverse direction, there's almost no current flow. Resistance is very high in the reverse direction. Describe the disadvantages and advantages of parallel circuit to the series circuit. Advantages. Current flowing through each bulb in the series circuit is half of current flowing through each bulb in parallel circuit. Bulbs connected in parallel glow more brightly than in series. When a light bulb in parallel circuit blows, the other bulbs in circuit continue to work. Current flowing through battery in parallel is 4 times the current in series. That is the disadvantage, which result in this. The source in parallel circuit will provide larger output and therefore depleted more quickly. Explain the hazards of electricity. Damaged insulation. The insulating materials become worn with time, exposing the conducting wire, causing short circuit when the live wire touches the neutral wire, resulting in unusually large current, resulting in overheating of the wire. The exposed wire causes electric shock when you touch it. Overheating of cables due to overloaded power sockets. When power socket overloaded with many appliances, unusually high current flow through the wire due to decreased effective resistance at constant EMF. Overheating of cables due to inappropriate wire, since resistance is inversely proportional to cross-sectional area. Thin wire has higher resistance to generate more heat compared to the thick wire. Then environment. Water in contact with uninsulated wires provide conducting path for current. The body of human will experience a large current causing burns. Explain how the switch should be placed on live but not neutral wire. When electrical fault results in live wire touching metal casing. If switch is fitted on neutral wire, the metal casing is still connected to the live wire when the switch is open. Metal casing is at high voltage of 240 volts. When the person touches metal casing, large current flow through the person to the earth and the person gets an electric shock. When switch is fitted on the live wire, metal casing is disconnected from live wire when the switch is open. Metal casing is at low voltage or near 0 volt. No current flow through the person touching the casing. Explain the importance of earth wire. Without earthing, when electrical fault results in live wire touching metal casing is at high voltage. When a person touches metal casing, large current flow through the person and person get electric shock. With earthing, large current flow to ground through the earth wire, which has lower resistance than the person. The person will not experience electric shock. As effective resistance increases, flow of large current from live wire through metal casing creates short circuit. Sudden surge in current, it should be decreases. Sudden surge in current exceeds the fuse rating and the fuse blow to create open circuit. The electricity supply to appliances is therefore cut off. How double insulation works. Electric cables insulated from internal components of appliances, internal components insulated from external casing. Explain the process of magnetic induction. When the north pole of a permanent magnet is brought near a magnetic material, the end of material closer to north pole of the magnet becomes induced south pole, while the other end becomes induced north pole. Attraction between north pole of permanent magnet and induced south pole of material is stronger than repulsion between north pole permanent magnet and induced north pole material. The material is attracted to the magnet. How to magnetize magnetic materials using electrical method. Place the magnetic field in solenoid with DC supply. When large DC flow through the solenoid, a strong magnetic field is produced. Magnetic field align the magnetic domains in the steel bar. How to demagnetize magnet using electrical method. Place the magnet inside solenoid in east-west direction. Connect solenoid to AC supply. Withdraw magnet with AC still flowing in solenoid until it is distant away. How magnetic shielding works. Magnetic field lines coming out of north pole prefer to pass within the soft iron sheet or core than the air. Field lines after passing through the soft iron core force to come out and enter the south pole of magnet to form closed loops. Region on side of soft iron sheet or equipment placed within is free from magnetic field. Explain how circuit breaker works using principles of electromagnetism. When the switch is in on position, current flows through the solenoid and the stationary contact. When the current is below limit, the magnetic field of solenoid is not strong enough to attract the soft iron latch. Safety bar stays in position and interrupt points remain closed. Current still flow normally through a circuit. A short circuit or overloading results surge in current. Larger current makes solenoid a stronger electromagnet to attract soft iron latch. This releases the spring and pushes the safety bar outwards, such that the switch is in off position and interrupt point open. There is a break in the circuit and current no longer flow through it. To reset the circuit breaker, push the switch back to on position and close interrupt point and resume default mode. Describe the structure of DC motor. A rectangular wire coil is mounted on axle, causing it to rotate. Coil and axle position between poles of permanent magnet. Coil connected to split ring commutator, which rotates with coil. Two carbon brushes press lightly against commutator. Explain how DC motor works to ensure coil rotates in the same direction. Using Fleming left-hand rule, downward force acts on wire section AB and upward force on CD. It would be better if you have a textbook to refer for the diagram. Coil rotates anti-clockwise about PQ until vertical position. Current is then cut off as split ring commutator is not in contact with the carbon brushes. Momentum of coil carries it past vertical position. Direction of current flowing through sections AB and CD is reverse. Upward force acting on AB and downward force is on CD. Coil continue to rotate in the anti-clockwise direction. Explain how induced current is formed. Do refer to a textbook for the diagram. When the south pole of the bar magnet was moved into the solenoid, the galvanometer needle deflected momentarily to one side. By Faraday's law of electromagnetic induction, due to rate of change in magnetic flux when the magnet was inserted, EMF was induced in coil and current flowed through the galvanometer. And larger the rate of change in magnetic flux, larger the magnitude of induced EMF and current. By Lenz's law, the induced current produced a south pole at end of solenoid to repel the south pole of bar magnet, and direction of induced EMF and current is as shown using a right-hand grid rule. Describe the structure of AC generator and how it works. A rectangular coil is mounted on the wire. When handle is turned, the coil rotates between poles of two permanent magnets. As the coil rotates in magnetic field, the change in magnetic flux creates induced EMF and induced current in the coil. Slip rings are in contact with carbon brushes as the axle rotates. Slip rings ensure induced current in coil is transferred to the external circuit. Explain the output voltage against time graph for AC generator. When the plane of the coil is parallel to the magnetic field, arm AB and BC cut across the magnetic field line at the greatest rate, hence magnitude of induced EMF is maximum. When the plane of coil becomes perpendicular to the magnetic field, arms do not cut across the magnetic field line. Since rate of change of magnetic flux is zero, the magnitude of EMF is zero. After the coil rotates half a cycle, it's parallel to the magnetic field again, and magnitude of induced EMF is maximum. Direction of induced EMF is now opposite. Arms AD and BC of coil do not cut across magnetic field lines, and magnitude of induced EMF is zero. Coil has rotated one complete cycle and parallel to magnetic field again to produce maximum induced EMF. Explain or rather describe how transformer works. The primary coil is connected to alternating voltage input voltage. A varying magnetic field is set up in the laminated soft iron core. EMF is induced in the secondary coil, which is the output voltage, and produce induced current in the coil. Why is laminated soft iron used? The soft iron is used as easily magnetized and demagnetized, and this ensures better magnetic flux linkage between the two coils. Lamination reduces heat loss by eddy current. Describe measures to reduce Joule heating in wires and disadvantages in the measures. Use thick cables to reduce resistance, power loss as heat is reduced. However, thicker wires or cables increase cable and construction costs. So reduce magnitude of current flowing in current using step-up transformer. When voltage is stepped up, current in cable is stepped down as P equal to VI and power is constant. When current decreases, since P equal to I square R, with current decreases, power loss is also reduces. Better to say power loss decreases as heat reduces. How CRO works. Cathode ray tube in vacuum glass tube with electron gun, deflecting system, and fluorescent screen. Electron gun emits a beam of electrons produced by the cathode. A bright spot is created when the electron beam strikes the fluorescent screen coated with zinc sulfide. Large number of electrons striking the screen brighter the spot. Varying voltage across Y plate changes vertical deflection of the electron beam. Varying voltage across X plate changes the speed of the electron beam sweep horizontally across the fluorescent screen. How to measure short interval of time using CRO and speed of sound. Connect the microphone to Y input terminal. Clap once near microphone to produce the pulse of sound. Sound received by microphone and shown as signal on CRO screen. Sound pulse is reflected by the wall and microphone receive echo and another signal shown on CRO. Number of intervals between two signals can be used to calculate time taken for sound pulse to travel from CRO to the wall and back. The speed can be calculated by taking the 2 times the distance between the hands and divide by the time interval between the two signals. Describe how sound is produced in air. This is the last question that I will go through. Take a look at it first. When vibrating source vibrates, the air molecules need to vibrate faster and collide more frequently with the neighboring air molecules. The air molecules are displaced and oscillate left to right about equilibrium positions, creating regions of high and low pressures, resulting in compression and refraction regions. The process is repeated as a sound wave propagates as longitudinal wave in a direction parallel to the direction of vibration of air molecules reaching the other end. So that's it for my standard list of questions and answers. I hope it will be beneficial to you. Hopefully, some of them will appear in this year O-level paper. Some of these appear in the previous year, so let's see how it goes. If you want to know the estimated or predictions of this year paper, do refer to my video. Yep, can check it out on my predictions on GCE O-level physics. Thank you very much and have a nice day. Wish you good luck in your exam.